Good morning, everyone. Today we are going to discuss a topic of sets and the queues. In a collection framework, we already completed with the list interface. List actually what it will do is it will store the elements, but it can store the element duplicates also, and also the list can maintain the insertion order. That means in which way you are storing into a list, that is the way order it will be maintained. It will be we are observing the list interface. In the list interface, we are discussing the concepts of array list, vector, linked list, and stack. Right. Today we are going to discuss a topic of sets and the queues. First, we can discuss the sets. Sets is from the set interface. Like a list, set is also an interface. What is the specialty of the sets is sets can store the unique element. Stores unique element and not maintains the order. Not maintains the order in the sense, suppose you are adding in the order of, that means storing the elements in the order of 1 2 3 4 5, but it will store somewhere in the 2 3 1 5 4. That means we are not guaranteed with the order. It will be stored in any order. We can't guarantee it. That is one thing. Stores set, when you are discussing about a set, you have to be remember the two things. One is stores unique elements and second one is not maintains the order. These are the two things. And in the types of the list, we have the hash set, linked hash set, and a tree set. These are the three types we have. Hash set is nothing but hash set stores the element same like what the set will be do, the same way it will be stored. That means stores the unique elements, not maintains the order. Then comes to the linked list. What it linked hash set, that what it will do is it stores the unique elements, but it maintains the order. Why it will maintain the order is, suppose how the linked list or the linked things can be stored is, suppose one element can store at one location, other element can store at other location, they can be maintain a link, right? So it will not main or stores in a continuous memory location, so it will maintains the order. In the linked list, it maintains the order. It maintains the order. And comes to the tree set. Tree set, it not maintains the order and it will not stores, that means it will stores the unique elements, but the difference between the set is stores the elements in a sorted order. Tree set, what it will do is it will stores the elements in the sorted manner. In which order you can give, but it will be stored in a way of sorted. These are the three types we have in the sets. Okay. Some more other sets also there, red bag set, those are the different, but these are the main three sets what we are taking. Hash set is the basic set interface type like an array list. This is the linked hash set, means it will stores the elements, that means unique elements, but it will maintain the order. And it comes to the tree set, it will stores the unique elements in a sorted order. That is about the set intro. Normally the way of how can you storing the elements, like add an element to the set, remove an element from the set, or you have to update. Updation is not possible. Okay, suppose you want to modify, then you can do. We all see that methods, and traversal is the same, but here you are not doing the one traversal approach. What it is, you cannot access through the indexes. Why? Because it is not possible to access through the index. Why? Because it will not maintain the order, right? Then how can you access through the indexes? So it is not possible to maintain the indexal traversal. We can perform the operations. How can you declare normally a set method is normally like a set interface. Suppose you want to mention here the data type, which type of data you are intend to be stored. Suppose you want to store the string, then mention the string set1 equals to new hash set. You can use the hash set, or else you can use the linked hash set, or else you can use the tree set. What's the problem? Okay, this is the way of you can create a set. This is one way by using the hash set. Suppose you want to create the linked hash set, you have to use the linked hash. Suppose you want to create the tree set, then you have to go with the tree set here. Or else you can mention hash set here also. You can mention the linked hash set here also. You can mention the tree set also. Anything. If you observe this, something problem. Okay, set1 dot add. Suppose you want to add an element, you can use the add method. Suppose 1, suppose I want to store the same thing, set1 dot add of hello 1. The same, if I want trying to add, it will not throw any error, but it will accept only the one element. It will checks only the one element. That means it will be stored in the set with the only one element. It will not accept this duplicate value, and also it will not throw any error. Wait a minute, I can create a new class. What is the problem with it? Fine. Now it is fine. Fine. Suppose if I can print set1, here I want to import if I run this, it will print only hello. That means it will print the set with only hello. Here my expecting output is with only the hello. Right? It only the hello, but I am adding the two elements here, but it will stores only one element. Why? Because set stores only the unique element. Suppose I am intend to add another element of hi, then now I can run hi hello, but it will not maintain the order. If you observe that hello was first inserted, hi was next inserted, but it will stores in the order of hi is at first location, hello is at second location. It will not maintain the order. It will only concentrate about the storing the unique elements. Why it is used is because of suppose when you are dealing with the real world problems of you are intent to storing the all usernames or the all emails. Username should be unique, right? Suppose if you have to check, suppose you have to store another username, then it will be throws the issue. The like way when you have a necessity for storing the only the unique things, sets can help to us. Okay, and in the way how can you remove is the same way you can use the remove. Here also you can use the add all, set one dot add all, set one dot add all. Here you can pass a collection. Here you can pass a collection. Suppose here I can create an array list. Array list integer equals to list equals to new array list. I am creating an array list. What I am doing is I am adding some elements to that array list. List one dot add of one. Okay, and it is also I can change to the integer. Why? Because I am try to add that array list into that I am storing the integers only in the sets and also in the array list. Suppose here I can add the list one, right? List one dot add of also one, right? Now it will, if I print the list one here, if I print the list one here, then it will print one and one. If I pass this list to the set, then what it will do is it will stores only the one element. That means it will be taking only one element from this list. One is actually duplicate in the array list, but it will not accept the duplicate. So your set becomes only with the unique elements. Normally, suppose if there is a case you want to convert or you want to remove the duplicates from a collection of elements, then simply you can make that collection into the set. Simply you can make that collection into the set, then it will becomes unique elements, the set with a or data with the unique elements. Okay, then how can you remove is simply like a set one dot remove. Suppose you want to remove one element 10. If the element exists, it will remove. If not exists, it will not do anything. Okay, it will remove the 10. The same, what are the methods you are using in the array list, those all can be applicable, but the thing is it will stores only the unique element. And also you can use the size method, sysout of set one dot set dot size or set one, right? Set one dot size, set one dot size, then it will return the length of the set. Then it will return the length of the set is 3, right? After removing I am checking, right? So it will be the 3. Before removing it will be the 4. After removing I am checking, right? So it will be the 3. And the same way you can check for the contains, that means one element exists in that or not. What are the methods you are already discussed in the array list? What we are discussed, right? We discuss add all, remove all, and size. You can use the clear also. Clear is nothing but it will remove the entire thing. It will clears your entire collection. Clear also you see, and you also see the contains, right? Contains is method. What it will do, it will be search for the element exists in that or not, and we are do that contains all. Contains all, what it will do is like here you are checking the one element exists in that not. Here you are checking the multiple elements exist in that or not. That is the contains all. Like that, what are the methods you are applicable in the array list? Those all can be you are applicable in the sets also. But the difference is it will be store the unique elements. And what is the another advantage of the sets is comparison between the collections. Suppose here I have a set 1, right? I am making this to the set 2. Instead of array list, I make this to the same the set. Okay. Here I can take the any set. Okay, has set. Fine. I can make this as a list to set 2. I think you all of you know that subset, superset we already learned in mathematics, right? Comparison of the sets, Venn diagrams, comparison of the sets. Nothing but suppose you have to be compare the two things. Here I have a 2, 1, 2. Suppose I have the, here I have set 1, right? Set. My set 2 contains, what the set 2 contains? 1, 2, right? What the set 1 contains? I comment this for a while. What the set 1 contains? Set 1 contains the 1, 2, that means what are the set 2 contains, and also 10, 20 and the 30, right? This was the set 1 contains. Suppose if you tell me all the elements in the set 2 are in the set 1, right? So set 2 is a subset of set 1. Set 2 is a subset of set 1. Subset means if all the elements of one set exist in the other set, then it is a subset. I can explain with the Venn diagrams. Okay, suppose it is set 1, I have another set, it is a set 2. Set 1, set 2. What the set 1 contains? Set 1 contains the 1 and 2, right? Set 1 contains the 1 and 2, and set 2 contains, sorry, set 1 contains the 10, 30, 20, right? And set 2 contains the 1 and 2. Set 1 also contains the 1 and 2, right? So 1 and 2. So which are both are sharing, we are calling it as an intersection part. It is an intersection part, right? And it is a only set 2 part. It is only set 1 part. Like the things are the same. Suppose you want to know the intersection, set 1 dot intersection of set 2, it will returns the common elements in the two sets. If you want to perform union means a combination of set 1 plus set 2. What are the combinations? Suppose my set 1 contains the other elements of 3, 4 and 5 also, okay? Except what is the set 2 elements? 1, 2, 3, 4, 5. What is the set 1 elements? 10, 30, 20, right? 10, 30, 20 and 1 and 2. These 5 contains the set 1, these 5 contains the set 2, right? What is the both contains 1 and 2? This part we are calling it as an intersection. and it is we are calling it as a difference, set 1 minus set 2, and it is we are calling it as a, it is also difference, set 2 minus set 1. And union means if you combine all the things, what will be the result? 1 2 3 4 5 10 20 30, that is the union. If you are combining entire the things, it will be the union. And subset is nothing but, suppose one set of elements exists in that other set. Suppose if in a case 3 4 5 is not, okay, 3 4 5 is not in that set 2, imagine that, then 1 and 2, set 2 contains only 1 and 2, this already exists in that set 1 also, right? So set 2 is subset of set 1. Now set 1 is superset of set 2. Why? Because set 1 contains all the elements of set 2, so set 1 is superset, set 2 is subset. Context is different. Another thing will be the same, context is different. These are the two terms. And disjoint means if it doesn't have any common elements, both the sets have not at all any common elements, then we are calling it as a disjoint. Okay, suppose set 1, this is set 1, right? Here we are in set 2 into the set 1, then it will becomes 1 2 and all the things. After that I can add some more elements to the set 2, set 2 dot add of 3, okay, and here I can print the set 2. Set 2 contains, right? Set 1. Now what I am doing is I am checking that sys out of union. How can you check the union is, you can check the union in two ways. You can perform the addition operation, or else you can use the method. Suppose union, I am printing that set 1 dot union set 1 plus set 2. I think union method not contains. In Python I think contains. Here set 1 plus set 2 can be work. This is the union. Intersection means suppose you have only the common things you have to find. Normally it is the concept you have to be achieved. When you are performing the set operation, they are asking to find the intersection between the two sets. Then what you have to do, you have to write a logic for print the unique elements. You have to print the unique elements. I think, wait a minute. Control V. I can make it as a set 3. Then I'll do one thing. Set 3 equals to set 1 minus set 2. Right, fine. Methods are not exist, so you have to write a logic for implement this. Once I can check, right. Add all is the method for the union. Add all is the method for union. Retain all is for the intersection. Remove all is the difference. Remove all, you can find the difference. And contains all, you can check the subset. Right, fine. We already performed the add all, right? Add all, what it will do? It will be perform the union operation. Suppose if you are go with the retain all means it will, okay, intersection, right? In the intersection, set 1 dot retain all of set 2. Suppose set 2, that means it will print only the what are the common elements in the both. The common elements in the both is 1 and 2, right? So it has to be print only the 1 and 2. Intersection is true. Normally what it will check is, it will check intersection exists or not. Suppose I can make this with the set 3. Set 3 not contains anything, right? So set 3. Now I can compare. Set 3 is an empty set, so empty set is an intersection to the everything. So I can add some element to the set 3. I'll do set 3 dot add of 3. Okay. That's true. Keeps the elements only in the, wait a minute, then I'll do one thing. Set 1 equals to set 1 dot retain all, type mismatch boolean to string, boolean, right? It is always so. What is the set 1 contains 1, 2, 10, 20, 30. True. We'll check that. Okay. We are not intent to be do. Suppose set 1 dot retain all of set 3 or set 2. Then what I can do is, again I can print here the sysout of set 1. Okay. Now I can observe the difference. Set 1 already before contains the 1, 2, 10, 20, 30. Now it will print only the intersection of elements. Right, now it will print only the intersection of element. That means you are not intent to print the in a print statement. You have to be write as a separate statement. Then what it will do is, it will modify the set 1. It will modify the set 1 with the only the common elements. Suppose you want to perform the that means difference, that means set 1 minus set 2. Then for a while, set 1 minus set 2 means set 1 dot remove all of set 2, right? Set 1 dot removal of set 2, that means what it will do is, it will remove the set 2 elements in the set 1 and will remains the set 1, and it will print 10, 20, 30. It will not maintain the order. Insertion order it will not maintain. Suppose you want to perform the subset, right? Subset method is contains. You can check contains all. In the contains all, set 1 contains all. It will be print what are the elements you have. Suppose set 1 dot contains all of set 1. 120, 210, 30. It will not modify anything. I can make it to the set 2 dot contains all of set 1. I can make this in a for a while. First I'll check like this. Not at all anything. I can check the set 2 dot contains all in a print statement. It will check set 2 all contains that set 1 collection elements or not. So now it will be print false. Why? Because set 2 what the element contains 1 and 2. Sorry, set 2 contains only 1 2, but you are checking that 1 2 with the all the elements. Suppose now it will be prints 2. I think so. Why? Because set 1 already contains the 1 2 20 10 30. Your set 2 contains only 1 2, so these are all elements in the set 1, so it will return 2. But in before what you do, set 2 dot contains all of set 1 means set 2 contains only 1 and 2, but you are checking 1 and 2 with the 10 20 30. These 5 elements not in that set 2, right? So it will return false. If contains, it will return 2. This is the way you can perform the set operation. Basically set operations is nothing but you have to compare the two data collections, then set operations help to you. So add all means union, remove all means difference, retain all means intersection. Right? It is the sets. It is about the fully the sets. Next we have to discuss the queues.